Hi all, I just want to make this short video to help answer some of the questions I was getting this week in the first part of chapter 4 and to kind of tie it all together, hopefully, so you can see how it is all related. What I have here, of course, you know what you've learned so far about your trig functions is that they are simply the ratio of sides of a triangle from a certain angle. So we're just going to call that angle theta for a minute, and the sine of theta is always going to be wherever that angle is. Take the side that's opposite that angle, divide by the hypotenuse, and you have the sine. Cosine is adjacent over hypotenuse, tangent opposite over adjacent. You may have remembered from high school a little phrase SOHCAHTOA to help you kind of remember this. SOHCAHTOA. And of course you got your reciprocal functions. Cosecant is the reciprocal of sine, so that's now hypotenuse over opposite, and so on. So these are your classic definitions of your trig functions, but as you notice throughout chapter 4, you've got a lot of different definitions for your trig functions, and I kind of wanted to just put this together to show you how they're all related. And we're going to start with some very common right triangles. So I have two of them here for you. This first triangle is considered a 30, 60, 90. I'll put the 30 degrees up here. And of course, you've realized in this course that you must be able to work in both degrees and radians, and you've got to know these interchangeably. So you almost have to memorize 30 degrees is pi over 6, 60 degrees is pi over 3, 45 degrees is pi over 4. They are some of the common ones. And of course, know your quadrant angles. Your 90 degrees, your 108, you have the 180, 270, 360. Make sure you're familiar with the conversion between degrees and radians for those angles as well. So let's take a look at this first triangle. This is considered a 30, 60, 90 triangle. And this one, of course, is a 45. Now, if one angle is 45, the other one has to be 45. 45, 45, 90 triangle. So from these two triangles, we actually get three angles to work with. We get the 60 degree, the 30 degree, and the 45 degree. What's nice about these triangles is they have some nice ratios. So for example, if I start off by saying this side is length 1, the side across from the 30 degree angle, the side across from the 60 degree angle has to be square root of 3 times that. Any triangle that is a 30, 60, 90 has that ratio. The longer side is square root of 3 times the shorter leg. Okay? Now, use Pythagorean Theorem. 1 squared plus square root of 3 squared equals 4, right? Because 3 plus 1 is 4. And take the square root of that, and you get 2 for the length of the hypotenuse. All right? Now, again, if I were to make this triangle much larger, you wouldn't, and this were now a 2, you know, they would be doubled. They would still have the same ratio. Because when you take a ratio, you take one side divided by the other side. It doesn't matter how large that triangle is, it's still going to be the same ratio. So we use these numbers because they're just kind of the neatest numbers that we can come up with. So for the 45, if that's a 1, this is also going to be a 1. Okay? And then 1 plus 1 is 2, and this hypotenuse is, of course, square root of 2. So when you're looking to find the sine, say, and I'm going to use the radian functions because it's just a lot easier to work with, and you need to get used to them. So suppose I wanted the sine of pi over 3. I would have to go to where the 60 degree angle is, which is pi over 3. Use the ratio of opposite over hypotenuse, and of course your sine of 60 degree angle is square root of 3 over 2. Now, if I wanted the sine of the 30 degree angle, which is pi over 6, I then have to use the angle that's up here. Now when I say opposite, the opposite of that 30 degree is directly across, and it's a 1 over hypotenuse square root of 2. So with 30, 60, 90s, we can use the same triangle, just different sides of it. And of course, the sine of a 45-degree angle, which is sine of pi over 4, is going to be opposite over hypotenuse 1 over square root of 2. We always rationalize our ratios. So you have to remember how to quickly rationalize. Square root of 2 over 2. So it becomes square root of 2 over 2. All right, you multiply by square root of 2 over square root of 2. And you'll start to get these memorized to the point where you'll know, oh, sine of pi over 4 is square root of 2 over 2. Okay, if not, you will draw out your triangles. So these two triangles you need to commit to memory because we are going to use those basic angles for a lot of different things. Now, how does this relate to our unit circle? And that's what I wanted to go over with you for 1 second. Because in chapter 1, you read about a unit circle. Now, in a unit circle, okay, and throughout, I'm sorry, not chapter 1, section 4.1, in a unit circle, it said something like sine of theta equals, I believe your book used t, it didn't matter what it used. But you saw a lot of different formulas, and you say, oh, well, that's just y. And cosine of theta is just x. So how do we get from our ratios to this idea that sine of theta is y and cosine of theta is x? So here's what I want to do. I'm just going to draw a basic unit circle. And if you look in your modules, what I have for you is a completed unit circle with all the actual trig functions, and you don't need to memorize that. Please don't attempt to. You really only need to memorize these two triangles at the top of the screen. Because you can, what I will give you on the test is a blank unit circle, and you can fill in what's needed. And that's also in the module for course information. You have a filled out unit circle and a blank unit circle. So let's talk about these two triangles I have up here and how they go on a unit circle. On a unit circle, what's so special about it is the radius is always 1. So it's a negative 1. So no matter where I draw my radius along my unit circle, so let's draw a 45-degree angle, because that's the easiest one to draw, because we know it's directly in the middle. Okay, there's a 45 degrees. So my theta now is 45 degrees, which we know is pi over 4. Okay, but it's a unit circle. And because it's a unit circle, my hypotenuse must be a 1. Well, take a look at the triangle I have up here. How do I make this square root 2 shrink down to a 1? Because this is what I have. For my 45-degree angle, I've got square root of 2, 1, and 1. But I need to convert that, still having a 45-degree angle. Oh, well, you divide by square root of 2, right? Isn't square root of 2 divided by square root of 2 a 1? There. And that's fine as long as you take the other two sides and divide out your square root of 2. Well, we learned up here that 1 divided by square root of 2 is simply square root of 2 over 2. And this length is also square root of 2 over 2. So now, how do I get the x and y value of that point? Well, your x value is this along the bottom. Does everybody see that? Square root of 2 over 2. Your y value also happens to be square root of 2 over 2. So that means for a 45-degree angle, my coordinate is square root of 2 over 2 square root of 2 over 2. So notice this x value is the adjacent angle. And if you take the adjacent angle and divide by the hypotenuse, you get the cosine, correct? but the hypotenuse is always going to be 1 because it's a unit circle. So square root of 2 over 2 divided by 1, that's your cosine, which is why cosine of theta is equal to the x value on a unit circle. So let me go through that real quick again. I'm going to erase this that I have here, and I want to do it with my 30, 60, 90 triangle. All right? Because we can see that a little better, because with 30, 60, 90, they're both not the same. So here's my unit circle back. Okay, not a very good unit circle, but it'll work. And let's draw a 60-degree angle. So 60 degrees is going to be up here somewhere, right? Makes sense? Again, not the best at drawing on these computer pens, but it's fine. And my theta is 60 degrees, which we know to be pi over 3. I'm going to use pi over 3. Okay, again, I have to convert it to a unit circle. So this hypotenuse right here is a 2. Well, divide by 2, turn it into a 1. In order to do that, I got to divide everything by 2. So this becomes square root of 3 over 2. And this becomes 1 over 2, or a half. This coordinate is now, your x value is 1/2, and your y value is square root of 3 over 2. So if sine, according to our unit circle, sine of pi over 3 equals square root of 3 over 2, which is the exact same thing we got up there. Okay? So when you convert everything down to your unit circle, because the hypotenuse is now just a 1 on a unit circle, only on the unit circle, when your hypotenuse is 1, your sine becomes your y value because it's opposite over hypotenuse. Well, the hypotenuse is 1, so it's just the length of the opposite side, which also happens to be the y value. And the cosine is the length of the adjacent side, which also happens to be the x value, which is also, if you want to think about it, tangent becomes, well, tangent, as you found in the earlier chapters, is sine over cosine. Tangent, you saw this identity, is the relationship of sine over cosine. So your tangent value is your y value divided by your x value, where x and y are coordinates on the unit circle. Okay, and of course you have your reciprocal functions, which you can see in the book are just the opposite of everything I gave you. Now this is very useful because once we turn this into a unit circle, and I will describe in the next video, okay, we can now do 30-degree angles, 45-degree angles, 60-degree angles, but not only that, we can also do angles that are 30, 45, and 60 degrees away from the x-axis. And that's where our reference angles come in that you'll learn a lot about in chapter 4.4, I believe. I don't know. I'm looking at an old edition of the book, so it might be 4.4. So I'm going to stop this video right now, but I am going to tell you one more thing before I stop. As we work on this, when you move on to sections 4, 5, as you move past section 4.5, we're going to take these graphs and we're going to label the x-axis the degrees or the radians, and we're going to be able to actually sketch where your sine angle is at 30, 45, 90, and so on. And that's where you will start to get the sine curve when we sketch our degrees to our actual ratios. So everything is related. throughout chapter 4. And hopefully